Hi, for this one, for the first question, it says state the null and the alternative hypothesis. So the null is the observed sales distribution does not differ from the advertised distributions. So that would be this, like what it is right here. It doesn't differ. The alternative would be observed sales distribution differs from the company's advertised distribution because it's an alternative to the null. So whatever the null is, the alternative is exactly opposite of that. Exact opposite of that. For question B from the same question, this is calculate the expected sales count for each package designed based on the advertised percentages. These are advertised percentages: 18%, 32%, 27%, 23%. So the formula is this: it's basically the percentage times the sample. So it's that times n equals that gets you the sales, the counts for each package. And that's these times 600, and it gets you these. So compute the chi-square test statistic. And you're going to be using this formula that we learned a long time ago. And these are advertisement expected sales. This formula. And so you plug these in, right? Because these are the expected. But the observed are the ones over here. These are the observed. These are the ones that they recorded, right? Observed. So the observed minus the expected divided by the expected. So you do it for each one, you get your answer, and you plot the chi-square distribution and critical value, and this is the formula for that. So there's four percentages. So that minus 1 gives you the what you use to get your z-score, or your critical value, I should say. And they gave us a significance level of 5%, which you turn that into 0.05, and you get your chi-squared like thing, you know. You get your your distribution and your critical value. Oh yeah, and for these, you add them all up into that. So these equal that. And there's a test statistic. And it says plot the test statistic. So you take the same graph from before and you put the test statistic. And since the critical value is this, since the test statistic is greater than our critical value at a 5% significance level, we reject the null. And for question 2, it says state the null and the alternative hypotheses. So the null is there is no association between diet type and physical activity level among adults. And the alternative, the exact opposite, is there is an association between diet type and physical activity level among adults. And column row and total. Calculate the expected counts for each cell in the contingency table. So the formula used for that is the row total times the column total divided by the total, and that'll give you. And for this one, as you can see, it was all the same. The column totals were all the same, so that's why that makes it easier, because you're gonna make it all the same. Compute the chi-square test statistic. So it's the same formula as before. The observed minus expected divided by the expected. And for these, you add them all up, and you get this very tedious process. And you get your test statistic, which is 31.234. And then it says plot the chi-square distribution and the critical value. So for this one, you're gonna use a different formula. It's the 3. So there's 3 minus 1. Oh yeah, it's because there's 3 columns. So 3 minus 1 and 3 minus 1 times each other, which is 2 and 2. 2 and 2 times equals 4. And this significance level was 0.05. So if you look at your z-score chart at 4 and 0.05, you'll get 9.488. And that's the critical value. And so you take the same graph again, and it says plot the test statistic. So this is 9.488, and this is the test statistic that was a lot bigger. So it's all the way over here. So since the test statistic is greater than the critical value, reject the null at a 5% significance level. A variable z follows a standard normal deviation. Calculate the following probabilities. Find the probability that z is less than negative 1.28. That is, compute p parentheses z. So for this, you just look at this on the z-score chart, and that'll get you 0.1003. That's pretty much what you do. Right? And for B, it says that is compute. So if you look on the z-score chart, it's 1.67. This is greater than 1.67. That gets you 0.9525. And you minus that by 1. So 1 minus 0.9525, and that gets you 0.0475. And this is compute. Find the probability that z is between negative 0.94 and 1.45. So you go on the z-score chart and you look at them, and you minus these, and that gets you your z-score, which is negative 0.7529. Find the z-score such that the area to the left of z is 0.975. So you look in your z-score chart to find this, and that gets you 1.96, according to the positive z-score chart. For question 4, calculate the sample proportion of consumers who prefer the new brand. Right, so in the homework, it used to always like this. I don't know how it is, but you take the indicated, the 275 indicated, and you divide that by the consumers, make it 0.55. So P sub hat equals 0.55, and the N equals, so the sample equals 500. Calculate the margin of error for your confidence interval. So this is the formula right here. It's P sub hat 1 minus P sub hat equals or I mean, that's not the formula. This is the formula right here. This is 0.55 times 1 minus 0.55. That gets you 0.2475. You minus that by the sample size, or the N, and that gets you 0.00495. 0.00495. And then you take the margin of error equals 1.96 times square root of 0.00495. That gets you 0.0436. So that's the margin of error for your confidence interval. So construct a 95% confidence interval for the true proportion of consumers who will for the new brand. Show all steps of your calculation, including the formula. So this is the formula, and these are the steps, right? You plug in your proportion sample proportion, minus your margin of error, and then you do it plus margin of error. So that gets you 5.5064 and 0.936. And this is your values. Interpret the confidence interval in the context of the problem. The confidence interval is 0.5064 and 0.5936. And we got this by subtracting our sample proportion with our margin of error to get the confidence interval. A competitor claims that only 50% of consumers prefer the new brand. Based on your confidence interval, is this claim plausible? No. Based on the confidence interval, this claim isn't plausible. It is not plausible because 0.50, so 50%, does not fit within 0.5064 and 0.5936. Doesn't fit within that range because it's 0.50. Determine the sample size needed to achieve a margin of error of the most 3%. So this is a formula you use, right? Bring it over here. So these are all your answers that you got so far. So you plug them all into here, into this formula. You plug them all into here, and you use the parentheses so like it can do it in the calculator, right? Because it's not gonna do it right if you don't do it in the with the parentheses. And that gets you this. So that answer would be determine the sample size needed to achieve a margin of error at most 2% is common. So this would answer be 1,000 percent. Discuss how the width of the confidence interval would change if the confidence level were increased to 99. Oh, look at this graph here. It was 95, right? This is what it was before. And you see the lines are right here. And if it changed to 99%, the lines would be over here. So it would get wider. The range would get wider. When we increase the confidence level, our critical value increases. So our confidence interval gets wider. Right? So if our confidence level goes up, our margin of error goes up. If our sample size goes up, our margin of error goes down. If our sample size goes down, our margin of error goes up. Right? So that's how it would change. If it increased to 99%, our margin of error, our confidence interval gets wider.